Let's construct a histogram for this 2018 SAT scores dataset using a more manual histogram creation method. Unlike using the histogram tool, which makes our histogram pretty much right away, but leaves us to have to customize it. This way we can choose our classes however we'd like, but the downside is we may need to find our frequencies sort of manually there. So let's try that. Let's construct our table first, our frequency distribution, which means we need to describe the classes we want to group these data points into, and then determine the frequency for each one. Now for this method, if you're going to do that sort of manually, you'll want to do that without a super huge data set. Here we have 50 data points, which is not completely overwhelming. This should be pretty manageable. But to make our job easier, we should take our data set and sort it. So highlight the column or just the data set that you're working with. And then in that home tab in the editing area, go ahead and sort it, usually from smallest to largest is the best way to do that. This is going to make it so that our smallest data points on top looks like 844. Our largest data points on the bottom, it looks like 1107. Whenever we're choosing the classes for our histogram, we have a little bit of leniency to do that however we'd like, as long as we're making sure that we include the same number of data points in each class, and also making sure that we start smaller than the lowest data point and end higher than the biggest data point. In this case, remember we want roughly between 5 and 20 bars or classes for our data set, so we can kind of make an estimation there. If you're doing this manual method, I recommend making it somewhat easy to read, and so we can break this down into, if you want to make lower class limits, LCLs, and upper class limits, we can do that. And then we'll do the frequency for each of those. So our first lower class limit should start somewhere below 844. I'm going to choose maybe 800 there. That may be a little low. But if we go from 800 to say 850, that might be a good way to do that. Now, however, be careful, because if we're doing this method, that actually does include 51 different SAT scores if we count both zeros. So it might be a better idea to jump up to 850 for the start of the next class, which means the previous one would end at 849. There's a way to calculate that a little bit more in detail if you want to, but this way what we're doing is we're setting it so that this does include 50 whole numbers of SAT scores, and our next would start at 850. Right? If we want to do that a little bit more carefully, we could specify the width of the class that we want and say, for example, in this case, we want a class width of 50. All you'd be doing there is we would calculate 800, which is our starting point, our first lower class limit, and add the width to it. And that's going to give us that same 850. If we fill that down or do that repeatedly, notice, be careful, that's going to add, what it's going to be doing is actually adding zeros because it's shifting that 50 down. So we do want to, once we've typed that 50 in there, we'll press F4 to lock that in so that when we drag our formula down, that doesn't change. Notice, coincidentally, this is the same as the number of data points. That's literally just a coincidence. I picked 50 there because I thought it would look nice. That's not anything related to the sample size. So now that we've updated that with the dollar signs or by pressing F4, fill that formula down and it's going to continue to add 50 row by row. 1150 might be too much. If we look at the largest data point, the highest SAT score in our sample was 1107. And so that we actually don't need to go to 1150. We can stop our previous upper class limit at 1149. And we know that's going to be enough. That is going to include all of our data points. So I'll delete that last one there. Again, you don't need to do that in your head either. Once we've determined really our lower class limits, we can take 850, which is our second lower class limit, and subtract 1 from that. That'll give us the ending point for the first class. And then we can do a similar thing to what we did before. We can take that first upper class limit and add 50, pressing F4 to add those dollar signs. Right? And then fill the rest of that formula down so that we get the correct upper class limits. Now, so we should have a place to put every single SAT score now, and all of the SAT scores in our table or in our data set should fit somewhere. And so let's find those frequencies. Remember, frequency is just a number of scores. And so what we're doing is we're just going to look through our data set and find how many SAT scores fit within each group. So here, there's only one that goes between 800 and 849. It was that very first data point, so we'll record a 1 there. From 850 to 899, I like to just kind of highlight the ones that look like they're in that range. It looks like these are the ones that I've found. We can just manually count those, but if you notice in the bottom right corner, Excel will actually count those for you. It says there's a count of 13 here. So that's my frequency. That's how many students earned an SAT score within that range. If we keep going there, we can look from 900 to 949. That's going to represent, it looks like, a group of 12 students. From 950 to 999, we can check that too. It's like a smaller group. It looks like only 4 students were in that range. From 1000 to 1049, looks like we've got 12 students there. For 1050 to 1099, I'm seeing 7 students with only 1 student being past that one. So we'll say 7 and then 1 will be our final frequency there. We can double check if we add those up. That should sum to the total number of data points that we have, which looks like it's 50. Looks like we got them all. That's a good way to check to see if you missed one or counted one twice. So it looks like our frequency table, our frequency distribution looks good. If we want to add a histogram for this now, all we need to do is highlight our frequencies, and we want to insert a chart there. We're going to choose the very top left option for a bar chart or a column chart. A 2D column chart is what we want there. Really, we just want to graph those frequencies all next to each other, and this is going to be a way to do that. Now, we do require a lot of formatting here, though, because technically this doesn't represent a histogram yet. Just for clarity, we can add some axis titles if we use add chart element there. I recommend doing that. We can title our chart based on the variable that we're measuring, in this case 2018 SAT scores. The vertical axis title are the Y values. Those are your frequency, or you could say number of students or number of test takers. Along the bottom, that's our data value unit, so this is SAT score. Now, obviously 1, 2, 3, 4, 5, 6, 7 are not SAT scores. What we want to do is we want to put in there our class ranges. And so we're going to have to do a little bit of modification to make that work there. Those right now, what it's doing by default is just numbering the frequencies that we've added in there. Additionally, for a histogram, we need to close the gap between those bars. We need to make sure that they're touching, that there's no gap in between them. So to do that, if we right-click and format our data series, we'll see on the right an option for gap width. I'm going to slide that all the way down to 0, and that's going to make it so that those bars will be touching. You can also, if you want, right-click on those bars and add data labels to them. What that's going to do is just show those frequencies above each bar. I like to do that for visibility as well. So now really the only thing we need to do left to make this a nice histogram would be to change that axis values down along the bottom there. And you can do that. What I would do first is in a separate column somewhere, maybe we could have, I'll copy or cut and paste this, we could have left a little space here to label our classes. So let's move this label down. If we want to just type some text to describe how that class looks, we could say that this first class, for example, is going from 800 to 849. You could type it this way. And then we could continue on from there, 850 to 899, and so on. And you'll notice, compared to the other method that we have using the histogram tool, you'll notice that it is a little more time consuming to do it this way, but it gives you a little more flexibility as you're creating your histogram. You can, as we've seen, you can choose these class limits sort of however you like, as long as we're including the same number of data points in each. This method gives you a nice way to sort of decide how you want those classes to look so that it's nice and easy to read. Now that we've got our classes set up there, what we can do is right-click on any one of those data values along the bottom row. So I'll right-click on this one. And if we choose to select our data, what we're doing here is we're choosing what shows up along that horizontal or bottom axis. So what we want to change is in the right side of this window that pops up, this horizontal axis labels, that's what we want to edit. So we'll choose edit and we'll highlight that text that we just created for each one. And then notice it updated already there, but if we choose OK, and then OK one more time, it's going to replace those counts, 1, 2, 3, 4, 5, 6, 7, just the index for each frequency that we didn't really need. It's going to replace those with the text of our actual classes that we wanted. Notice it's kind of wrapping text a little, so I'm going to make this a little bit wider. But you'll see from that point, it looks like we've got a nice histogram with bars touching there with frequencies on top. That's a personal preference. But along the horizontal x-axis there, we do have a nice set of class labels inserted there as well.